Okay, hi everyone. I'm happy to be here talking about testing pandas. So I'm just going to be sharing this from a notebook here. And I've actually executed the notebook. So for the sake of pleasing the demo gods, um, I'll just be sharing the notebook or not running it, just showing what it does. But if there are questions, I am monitoring the chat. So if there are questions, I'm happy to sort of go off script if necessary. So as Steve said, I do corporate training and I teach people. Well, I like to say that I teach people to tell lies with data, and I sell snake oil for a living. I teach Python and data science for a living. I'm also an advisor at a company called Ponder. Ponder makes a version of Pandas that allows you to scale out to multiple machines. So uh, super excited about the work they've done. And I also wrote the book Effective Pandas, which is a best-selling book on how to leverage pandas. So happy to be here, and thanks everyone for watching. So what we're going to talk about today is how I test pandas and some techniques for doing that. So if I can find my cursor here. Okay, here it is. Let's get going. Trying to, sorry, my screen is kind of being funky here. I'm going to stop my screen share and try and share again. Okay, sorry, my StreamYard is being weird. Let me see if I can get this working.
All right. We'll be well that running up and again as soon as we can. Hey, Matt. We're I can't hear you.
Can you hear me now?
Yes, sir.
Sorry about that. Okay, so I'll get going here. I apologize for that. So I'm going to load some data here, and I'm just going to use pandas to do that. And this is some data from a ski resort. I'm based out of Salt Lake, and so this is a data from a ski resort. So we're just going to look at doing some manipulation of this data and how we would change that. So let's assume that you wanted to summarize this. This is from the ski resort called Alta. You want to summarize this by week. Right now it's daily data, and so there are various things you might do. You might want to filter out certain columns. You might want to group by the date, and then you might want to do aggregations. And then maybe you want to make a new column. Maybe you want to add the name of the ski resort. Maybe the name of the ski resort changed over time, so you want to have some logic to do that. And then maybe you want a new column with the weekly range of the date of the temperature. So here's how probably a lot of people would do that. That uh, copy the data, because if they don't copy it, then they get some weird warning, and then they'd pull out some columns, and then they'd store that in another data frame, then make this grouped object to do the grouping at the weak frequency, and then they'd aggregate all the columns at this level and store that. And then maybe they'd pull off the date index and stick that into a column. And then they'd, say if the data is less than 2000, then maybe it's called Alta Ski Resort. If it's greater than 2000, then it's called Alta. And then they calculate a range. And when you do this, you get all these fun warnings up here. And it turns out that this doesn't even work. It doesn't even put in a location column in here because of this fun setting with copy warning. So maybe they go back and fix that. And so generally, most Stack Overflow ways of fixing that involve doing something like this instead of doing that. And I'm also putting in some other logic here to change the season based on make the season based on the year. So this looks like it works, and so this is like some basic logic here, and this is probably how most people write their pandas code. So I'm going to show how we can test that, and hopefully make it a little bit easier to use. So anyone who's read my book know that I'm like a big fan of chaining, and so I would not write that as multiple steps there. I'd rather write it as one long step. So here's an example of what I do. I put parentheses around that, and then in the first thing, like I would say, okay, I'm going to pull off my columns, and then the next thing I'd want to do is like, okay, maybe I'll do a group by. So I'll just chain that inside of the parenthetical here. I'm going to group by that and then aggregate that. And then I can run that and test that. And I can do each of these steps sort of in a chained manner. Eventually, I'll get something that looks like this. Now, this chain is a little bit long. You can see I'm just doing the reset index here. I'm assigning that Alta location and ski resort. And I have some logic down here that's a little bit more complicated to update the season based on the year. And I'll show later how to clean that up. But this is a chain that does the same thing as above, but when you run it, you don't get any warnings. And you also don't have any cruft, like I say, intermediate variables hanging around. Generally, when I'm working with data, I'm concerned with my input and my output. I'm not really concerned with these intermediate variables, much like I am with SQL, right? I write my SQL query, and SQL does a bunch of things, but I don't care about all the intermediate things. I just want the result from that. So once you've written it into a chain, and again, you don't have to chain, but I find that after years of writing pandas code, chaining makes my code a lot better. It's really easy to put this into a function. And so here I've created this function called monthly summary. And you can see that here is my logic of my chain right here. Now here I have refactored this a little bit. So I've made a get location function and a get season function. And you can see that there's the logic up there. But if you look at this chain, it's relatively easy to read. You see we take our data frame, we pull off our columns, we do our group by, we aggregate the different columns by the different aggregation functions. We reset the index, we create a T-range column, a location column, and a season column. And when we run this, we can get the output right there. So that is sort of what I consider best practices, starting with chaining and sticking things into a function. Once you've got it into a function, you're starting to use software engineering best practices rather than just sticking everything at the global level. Now, this allows us to do some debugging relatively easily. When I show chaining, a lot of people have this visual reaction to it that it's like the worst thing ever. And they're like, how do I debug that? And my comment to them is generally, well, you debug it the same way you debug your normal pandas code, but let me just show some examples of debugging it. One of the things that a lot of people don't know about is that pandas has this pipe method here. And the pipe is a generic method. You can pass in a function, and the function we're going to pass in takes the data frame, the current state of the data frame, and can return whatever it wants. Generally, I just return a data frame so I can keep chaining on top of that. But here I've got this nice little function called size. And what it does is it just prints an optional comment and then the shape of the data frame. So you can see, I mean, to debug this is relatively easily. I can just inject these pipe calls after each operation here. And this is kind of nice. This is actually pretty useful. You can see that like the first pipe call on my original data frames said I had 14,000 rows and 22 columns. After I removed my columns, I had 14,000 rows and 12 columns. And then I did a group by, then I only had 2,000 rows and 5 columns. And then I changed my index, and you can see that that made another column. And so this is really nice, just to debug what's going on along there. Here I'm just looking at the size, but you can do whatever you want inside of these pipe methods if you want to. So, I mean, if you really wanted an intermediate variable, you can do something like this, where I say, and let's make a function called store that takes a data frame as the first argument and returns, in this case, a data frame. And then we're going to pass in a name, and we're just going to make a global variable that it holds the current state of the data frame. So if someone really wanted that intermediate value there, like I could say, let's just stick in this pipe call right here. We're going to call the store function, and we're going to make a variable called after group. And then after I run this, it should work. But if you look down afterwards, after we run it, we do have this after group that is the intermediate state if you really want to debug that. So the complaint that like you can't debug chains, I think is not a valid complaint, and you can leverage pipe to certainly debug this. One of the nice things about this chain is now that it reads like a recipe, right? I'm doing each step one line at a time, and it makes it really easy to, again, put it into a function, and now I can share this function with others, but I can also test it as well. Now, that's kind of the 90%, the Pareto of like how I debug Pandas code. A lot of people will see those chains and they're like, well, how did you test that? I mean, and it's not that I came up with this chain and wrote the whole chain and then run it at the end, but rather I'm doing it step by step. I'm adding a line, testing it, making sure it works, adding another line along the way, and then at the end I will have my chain. Let me show you some other techniques that are useful. You can debug with Jupyter. A lot of people aren't aware of that. So here I'm going to leverage pipe again, and I'm just going to make another function here called debug. I'm just going to call the set trace, which is part of IPython. So I'm just going to stick that in right here. So after I filter my columns, right before I do my grouping, I'm going to stick in a debug there. And you can see that when I do that, it puts me into the IPython debugger. So this is very similar to PDB, the Python debugger that comes with Python, just has a few extra bells and whistles. But I can say like L to list where I am. You can see that I am right here in this debug line here. I can print my data frame if I want to and inspect that. I can go up in my stack. I can list where I am when I go up in my stack. You can see that now I'm now in the Pandas core common method there. I can go back down to my stack. I can go to the next line. I can go to the next line again. So you can just step through your code if you wanted to using this technique, and it can come in very useful, right? Understanding exactly what's going on, jumping into the code of what's going on there. So that is the IPython debugger. One thing to be aware of: make sure you either quit when you're done with that, because while this is running, your Jupyter notebook won't be able to run anything else. So another thing you can do that a lot of people don't know is you can debug after the fact in Jupyter here. So here I've got some code here, and I, people are like, how do you debug something in the future? Well, I mean, Jupyter makes it relatively easy. Here I typoed, I'm grouping by date 2 instead of date, and so I don't have a date 2 column. And when I run this, I get a key error. It says like, I don't know about date 2, and you're like, okay, how do I debug this, right? I mean, again, I'd probably just like comment out the lines and step through it. But if you didn't want to do that, you can do this cell magic here, %debug. This is kind of cool. It just drops you into the Python debugger or the IPython debugger where the exception occurred here. So I can say like L, where am I? And this is where I am. I'm at this line, raise key error. So I can inspect the variables at that point. What is the key? The key is date 2. I can inspect my object here, and I can see the object only has a date column. And then I can figure out, oh yeah, I typoed date 2 instead of date, and fix it. Another thing that you can do in Jupyter, if you're not aware, is you can put a double question mark after a method or a function, and Jupyter will show you the document. Well, it will not show you the documentation, it will show you the source code for that, which is pretty useful. So if you really want to like look at the source code, I recommend doing it inside of Jupyter. Will help you not break your flow and stay in there. Okay, so let's consider like other types of testing that you might want to do. We've shown like how you can create this code, how you can sort of walk through it. You can debug it with a print style debugging. You can debug it with a debugger if you want to. Let's show how you might test this. So I'm a huge fan of the PyTest library. If you don't have that installed, it's a third-party library. Recommend installing that. In Jupyter, you can say !pip install PyTest. And here, I'm just doing this all inside of Jupyter. Again, you don't have to do this in Jupyter. Generally, people would do this in like a continuous integration environment. But I'm going to write a file. So I'm using the cell magic here to write a file called alta.py, which just has my logic. I mean, if I wanted to like share this with other people, it'd be nice to have like a little file that you can share. And so let's just assume that this is like the logic that I'm going to share around, right? It's just taking my raw data and cleaning it up. And I'm going to just make a little test for this. So one easy way to do that is just say, let's take my raw data, which is the data before I pass it through this function, and let's just spit this out to a CSV text here. And so I'll just do that inside of Jupyter right here. And then I'm going to write another file, my test file here, and it's going to be called test alta. And I'm going to import the IO library from the Python standard library. And then I'm going to take that data that I just created right here, the first 5 lines. I'm just going to throw that directly in here as a global variable called data. And then I'll read a data frame from that. So this is basically taking the first 5 rows and running it through my code, right, my monthly summary code, and then doing an assertion after that. In this case, all I'm asserting is that the length is equal to 5, that there are 5 rows of data, right? So presumably this does work. Well, how do we know it works? Well, we have to run the test, right? And so to run the test, again, because I'm inside of Jupyter, I want to shell out to the environment. So I would say !PyTest, test alta. And when you do this, you can see that this fails. And you can come down here and you can see that it was not happy with that because it says this is only valid with a date time index, but we didn't get a date time index. We got an index here. And the issue here is that my alta code forgot to convert date into a date here. So up above, when I read my CSV file, I actually told it to parse the dates. And down here, when I was reading the CSV file, I didn't parse the dates. I just took the raw out. You can see here's my DF right here. And in my logic up above here, right here, you can see that I'm just reading that without parsing the date. So it complained about that. And so let's see if we can address that. And so what I'm going to do here is I'm going to say, well, let's assign date and make it a date time. And so we'll save this file, we'll run our test file again, and lo and behold, it now passes, right? We see the period there indicating that this test was successful. So that's a basic way to take your code. Again, I prefer chaining. You don't have to chain, but I think if you try it out, you'll probably like it. And then put it into a function and then use PyTest to write a very basic test around the raw input and the output and make some assurances that the code works. Okay, so let's get maybe a little bit more complicated here. There is for Jupyter a tool called PyTest, which is kind of nice. Again, third-party tool, so you'll have to install that. But I can say import PyTest and then run this auto config function here. And then when I have that, I can just put this cell magic PyTest at the top here, and that will run the code inside of the cell as if it were a PyTest. So I don't have to shell out to calling PyTest, which is slightly more convenient. Again, if I was doing this in configuration or in continuous integration or production, I would move these files, and so the GitHub action or whatever would call out and use PyTest to run this instead of PyTest. But if you're inside of Jupyter, nice little tool to have. Let's look at some other tools that there are. One is Pandera. So Pandera is a third-party library, and it lets you make assertions about your code here. So you can install this if you need to. And then I'm going to write a little test file called test Pandera. Okay, so what's this going to do? I'm embedding my logic here, right up here. But at the bottom here, Pandera has some integration with the hypothesis library, which is a property-based testing library. And what I did up here is I read my CSV file, right? And then I said, let's use Pandera to infer the schema from the raw, just that CSV that it read there. So the schema is like what the columns are, what their types are, etc. And then it's going to plug that into hypothesis. So I need to do a little hookup here. We're going to say hypothesis, given this Pandera schema, we want you to generate basically examples of data frames. And then basically what I'm doing is hypothesis is going to pass that in as a fixture into my test code, the samples that it generates, and then I'm just going to run my monthly summary function and then make assertions about that. In this case, I'm just asserting that there are 9 columns in the output of that. Now, in this case, Pandera can be a little bit slow to generate these examples here. So I did use this decoration here to add in some other things to make a hypothesis and Pandera not complain that it's taking too long. But at this point, I can, again, shell out to PyTest if I want to, or I could use IPyTest and say, test this Pandera code. And it says that it works. It also gives me a little bit of warnings here, but we'll ignore those warnings. The Pandera code did work. Here's just the example using IPyTest. And when you use IPyTest, it seems to give us the same result. It says that one of our tests passed in 0.36 seconds. So this is kind of nice in that we are not hard coding the data in this case. In this case, Pandera and Hypothesis work together to generate new samples, and we can test our code to see if our code works with these new samples that it may or may not have seen before. Another library to use is called Great Expectations, somewhat similar to Pandera. Great Expectations allows you to make assertions about basically your schema or the data that you have. So the basic usage of this is you do something like this, where you say, I'm going to load the Great Expectations library, and then I'm going to take a pandas data frame, and then I'm going to call the from pandas here. So we are getting, in this case, the results of our monthly summary, right? We're not using the raw data here, but we're using the results of that. And after we do that, we can do this thing here where we can say, like, okay, given this Great Expectation data frame, it's like an extension of a data frame here, has a bunch of methods on it. And you can say, like, I expect column values to be between. So you can say, like, I want T max to be between -18 and 86. So you're generating these expectations here, and it spits out this little JSON blob from that. And then after you've got, here I'm just doing one of those, but you can make multiple expectations, and you can do statistics, that the mean is within some range of some value, etc. And then you can save this into a suite. And once you have that suite, then you can run tests against the expectations there. So here, what I'm going to do is I'm going to write a bad JSON here, and you can see that I'm just like manually changing this. I'm saying, like, for the Tmax, I want the minimum temperature to be 39, which I think is a little bit too high for Tmax. And so this is going to fail when we run that. So I'm just going to, again, I'm going to use IPyTest, and I'm just going to run my test Great Expectation test down here. You can see that down here I have a test Great Expectation. And I've got a little bit of boilerplate around this, but it's basically loading the JSON file, and then for every expectation or test suite in there, it's running it as its own test. This is using PyTest to do that, which is kind of cool, that PyTest, rather than saying there's a bunch of tests in there but fell on the first one, it's going to run all of the tests individually and complain about each of them individually here. So when you run that, we can see that in this case, this passed because I was using the good expectation, but if you want to, you could comment this out, and you could run this instead, and we would see that it fails because the temperature is not within a certain range. So that, again, I can run this if we want to. So let's run that, and said IPyTest is not found, and that's because I need to hook up the IPyTest here. So let me quickly hook up IPyTest, and I'll show that this. Yeah, just run this IPyTest autoconfig here, and then we should be good to go. Okay, so it's thinking here, and it should come up with our result here in a moment. Okay. Yeah, and so it's complaining. It says, like, I expect this column T max to be between these values, and it wasn't between those values. So we do have a failure there. So this is kind of nice in that, like, you can basically go through all of your columns, make these assertions that you want to, and then once you have those made, you can now run new data. You could use hypothesis to generate new data, and then you could run that against those assertions, or you could use this to do drift analysis over time, etc. So again, leverage that, stick it into PyTest, stick this into continuous integration, and certainly useful for testing. Okay, so that is my content here, and we got a few minutes left. Let's see, there's a question from Patrick. Patrick said, would you make an expectation for each function, or would you want to test in your code? Would you make an expectation for each function in your code base, or is that overkill? So here's sort of my take on testing, Patrick. I kind of want to test, have assertions around the input and the output, right? And so I want to make sure that what my, I like to make these tweak functions that clean up my data. So I want to make assertions about, like, the data that's coming out of that. If there's anything important or that I want to make sure happens, I would put an assertion around that, right? You can go down, like, the metric games of, like, every column has to have an assertion or whatever, and then people sort of make silly assertions just to make assertions, right? So I'm more of a lazy type, where it's like, this bit me once, I'm going to put an assertion in here so it doesn't bite me again in the next time. Matt Dupree says, how do you choose whether to use Pandera or Great Expectations? They're kind of different, right? I mean, Pandera will generate your data for you. Great Expectations will allow you to say this column is between a certain value. So different functionality there. Can we access the notebook? Yeah, if you want access to the notebook, reach out to me either on Twitter or connect with me on LinkedIn. Happy to get you access to the notebook. Patrick says, can hypothesis save schemas so the data file isn't necessary to run the test? So yeah, if you want to, you can manually create a schema if you wanted to, or you could save that if you wanted to as well. Yeah, Matt Dupree says, Kent Beck says, write tests until fear is transformed into boredom. Yeah, and again, this isn't necessarily like going down like how people test or whether you should do test-driven development or whatnot, but showing you that, like, certainly it is possible to test your Pandas code. Okay. Bruno says, how good is Pandera at generating data for hypothesis? It's okay. It actually, while I was creating this, I filed a bug with them that sped up the test, the creation of the data frame by quite a bit. But from my point of view, it could be quicker. Ludovico says, do you have any recommendation for testing Jupyter notebooks? We've used NBMake and NBEval. So I mean, I know that, like, people like GitHub, or not GitHub, Netflix, like, put notebooks into production. I'm not that type. My background is software engineering, so I'm more of a let's use notebooks for exploration, and then let's use software engineering best practices, make functions, put it into modules, test those modules, etc. So Okay, awesome. Well, thanks everyone so much. Again, reach out to me on Twitter or LinkedIn if you want the notebook. It's been a pleasure. Have a great rest of your conference.